here for those who can't make it. So basically, we stopped last time at question 55. So question 56 was calculate the capacity of the cylindrical mug. So whenever I see this question, capacity, I tend to just go, okay, what they want me to do here is to find the volume. So capacity and volume are exactly the same thing. So if you write that down, then you go, okay, I need to find the volume. The other thing is, if you look through your formula sheet, there is no volume for cylindrical. So now you have to remember that what we said was to calculate the volume of something, the first thing you do is you find the area that keeps repeating itself all the way along a certain length. So that means I need to find the area first of that circle there. And once I've got the area of that circle, I just time it by the height. And that's how you find the volume. So volume equal area time a certain length, or you can put height, it's up to you. Sometimes it's length. If it's a prism, for example, you need to calculate the area of that triangle, and then you time it by the length. Okay. And the area of a triangle, when you calculate, is just half the base times the height. So those are the things that they expect you to know at National 5 level. Now, what is the area of a circle? Two things I ask you to remember about circle: circumference or area, yeah? And they both start with pi. So what's the circumference of a circle? The way to remember it, what's the unit for area?
Squared.
So yeah, there's a square. So because there's a square, there's one that we usually call pi d and the other one pi r square. Which one is which? Because it's area square, you need r square for it. So that's an easy way to remember. The other one is just pi d. So we're looking for area, so we don't need the circumference. So first thing first, you need to calculate the area, pi r square, times the height, and that would give you 3.14 times. So remember, the radius here is half d, which is 5 times 14. And if you do the calculation for that, you would get 3.14 times 25 times 2 times 7. Okay. So what I've done, if this is a non-calculator question, I don't like decimal points when I do my calculation. So I can think, oh, if I time that by 100, for example, 25 is just 100 divided by 4. Then I get 314. I can time that by 7 and then time that by 2. It's much easier to time 314 by 7. And even if you think this is probably something difficult, you just do 300 times 7 plus 10 times 7 plus 4 times 7. So you find the value for that, 2100. 10 is 70. And 4 times 7 is 2 times 7 times 2, 28. So if this was a non-calculated question, you've got 198. Yeah? That is 314 times 7. But I'm not looking for 314 times 7. I need to now double it and divide by 4, which is the same as just dividing this by 2. Yeah? So how do you divide 2,198 by 2? You can just say it's close to 2,200. But I need to take away 1 once I get my answer. So instead of 1100, it becomes 1099, yeah? And that should be the answer, hopefully. And that would be centimeter cube. So one might say, oh, I'm happy to just use decimals. I can double that, or I can do 50 times this, and it's up to you. As long as you get the 1099, then you're good. And a capacity is a volume. So the other thing I've seen sometime ask is give the volume in milliliter. So 1 centimeter cube is just 1 milliliter. So it's 1099 milliliter. Okay. So that's quite a big mug, because this capacity here is about 1 liter, 1.1 liter. But you can think about 10 centimeters, quite wide, right, for a mug. And 10 centimeter by 14 centimeter, you can fill in 1 liter inside it. So have a good feeling of whatever answer you give. So if you had found something like 20,000 milliliter, just ask yourself, you know, in reality, that could be a genuine mug, but I've never seen a mug that can hold 20 liter. So the answer you give should always be close to what you would see in reality. Okay, so question whatever you put. That would be my advice. Okay, so the next one, I've got to factorize. First thing, I've got a lot of zeros here. But factorizing is trying to find a highest common factor, for example. So if I was to find a highest common factor here, they're all multiple of 100. So you can say this is 100 times x squared minus 5x minus 24. And that becomes easier now, because MAMS tells me I need to find two numbers. If I time them, I get negative 24. And if I add them, I get negative 5. Yeah?
Yep.
So now is the chance to look for two numbers. So I'm looking at 24. It's a multiple of 2. So I can do 12 and 2, but that's not going to get me close to 5 when I add those. Then I can say, why don't I try
3 and 8?
Yeah, 3 and 8, because 3 minus 8 would give me minus 5. And positive 3 times negative 8 would give me negative 24, and that works. So I've got negative 8 and 3. Okay. And this is you factorize it. You just put negative 8 there and positive 3 there. And remember to put the 100 as well outside. So this final answer would just be 100x minus 8 times x plus 3. Okay, so I've seen people losing a mark because they don't put the 100 there when they give their final answer. They just say, oh, I need to factorize this. But remember, we've asked us to factorize something. There's two parts in it. Not only finding 3 and 8, but finding the 100. Okay. Restaurant bill. If the bill was 324, what was the bill before the tax? So the common thing I've seen people looking at is the restaurant bill included 8%. If the bill was 324, what was the bill before the tax? So you just say that 108% is 324, because you've paid 100% plus added 8% tax on it. Okay. So if I want to find what 100% was to start with, I need to find what 1% is.
Mhm.
So you just do 324 divided by 108.
Yeah.
So if it's a calculator, it'd be quick. If it's not a calculator, then I would invite you to just half it, then half it again. Or you can say, oh, that's 4 plus 3 is 7, plus 2 is 9. So that's a multiple of 9. 8 and 1 is 9. So that's a multiple of 9. So you can divide both top and bottom by 9. So you've got wee tricks to help you. The one that I use quite regularly, if it's a non-calculator, is just half. So half of 300 is 150, plus 12 is 162, right? At the top. Half of 108 is 54. And now those are both even, so I can half them again. 81. Yeah. And 27, yeah.
Yep.
And now 81 is in the 9 timetable.
So it's 9 and 3.
9 and 3, and that's you. The only thing we needed to know here is the 2 timetable and the 3 timetable. And the 9 timetable, sorry. And the 3, obviously. Yeah. So if it's a non-calculator, remember what I said, a fraction should be a good friend to you because it helps you to divide by stages rather than putting. I've seen so many people going like, oh, this is 3 to 4. Oh, I've never done long division. How am I going to do this? And so you don't need to worry about long division. See this? We don't teach this at primary anymore. In my days, we had to. But
Yeah, that's how I got.
That's how I learned.
so that was long division. So we don't teach that. So they need to have an easy way now. And if they can half numbers, then most of the ones that I've got would be able to go through this without being scared of big numbers. Okay. So we've been putting off too many kids at school because they couldn't do things like that. They would come and say, oh, I hate math. So 3 is 1%, 100% is just 100 times that, which is 300. Okay. So does that make sense? Yeah. So the bill was less before I paid the tax. So you can quickly say, yeah, that makes sense. And 8% of 300 is 1% is 3 to divide by 100 times 3. 3 times 8 is 24. So 324. So you can quickly check that your answer makes sense. Okay.
Yep.
Next, I've got an angle to calculate. So I know this side, I know this side, I know this side. And I've been asked to calculate an angle. So I'm going to use a very well-known cos rule. So
I was trying to memorize that.
So I've got A,
one I had to
B.
use.
So I'm going to decide what is A, what is B, and what is C. We've got those 3 values. And A is just inverse cos of A squared plus B squared minus C squared divided by 2BC based on that. So that is from your
Formula sheet.
yeah, your formula sheet there. So maybe what's good is, yeah, I don't know if we're allowed. Yeah, you can take that formula sheet paper off. Maybe what I'll do is I'll try, I don't know who's going to print them though. I'll speak to. But yeah, if it's, I like to have my formula sheet next to me rather than going through
Yeah.
backward and back and forth.
Mm-hmm.
And what I usually put, I put the full, if I've not been asked to give it to a certain decimal point, I put the number with dot, dot, dot. And then I decide now if I want to give 1 decimal point, it's got to be 78.6. If I want to give 2 decimal point, it's going to have to be 78.58 because the third one is 4. So whatever you decide. So here they've decided 78.6, but technically they should put here, they've rounded to 1 decimal point just to keep you safe. Okay. Write down the turning point and the equation of the axis of symmetry. Yeah. So this is a tough question, I would say. Or we see people struggling with it. So what I would say to my student is if you get something like this, okay, this is how I would tackle the question. Let's say I come back in 20 odd years time and someone asks me this and I can't remember. I remember that I've got a smiley face and this is the equation of a quadratic equation. Why do I know it's quadratic? Because I've got x squared. So if I was to expand this, this would become x squared minus 6x plus 9 plus 4. Then I know I've got something in this format. A smiley face, right?
Mhm.
That point here
So axis of symmetry.
is my lowest point in terms of y. What is y concern? Is this is my lowest point. Okay. Now, when do I get my lowest point? This is always positive, right? When you square a number, it's always positive. If you square a negative number, it's going to be positive. Okay. Because this is always positive, it's always going to be added to 4. So 4 is my lowest point. Okay. When do I get 4? When this is equal to 0. If this is 0, y equals 4. So when is this equals 0? When x minus 3 equals 0. Do you agree? And how do I solve this?
Yeah.
By adding 3 both sides.
So
Either side.
0, 3 is be on your first points and 4.
So x equals 3 is when I'm going to hit the bottom.
Mhm.
So when x equals 3, y equals 4. So this is not to scale, but they've not asked me all this. But write down the turning point. The turning point is x equals 3, y equals 4. This is what we should be writing. Now the equation of the axis of symmetry is there for me now. It's just going to cut here. And that is x equals 3. So by trying to understand what I've got in front of me and drawing it, I've managed to extract everything I needed without having to remember, oh, this is x minus a plus b, the turning point is minus. So I think it's better to understand what you do than trying to remember a's and b's, because they can give you an a minus b, an x minus a, it could be an x plus a one day, and before you know it, you're just gonna do any miny mo, and you get a 50% chance of saying, is that minus 3 or is it 3? No, by putting what I think it should look like, I know this is 3. So let's do turning point when x minus 3 equals 0. So that's x equals 3. That's what I've just said. And then when x equals 3, I get y equals 4. So there you go. Turning point is 3, 4. And the axis of symmetry, x equals 3. Okay.
Yep.
And if they had asked me to find the intercept, that could have been another question. When this touches the y-axis, for example, that's what we call the intercept. That happened when x equals 0. Yeah, so x equals 0. So you would say negative 3 square. So x equals 0. I got negative 3 square, which is 9. 9 plus 4, 13. So when x equals 0,
No.
y equals 13. So you could say that this point here is 13. Okay. If they had asked me that question, what's the intercept? The y-intercept, because this is y and this is x. But because that wasn't part of the question, you don't get extra mark for doing this. You just move to the next question. So I've not looked at the vectors because there's no point me bothering you with vectors as it's not in the exam. Now find the equation of this line. Okay, so to find the equation of a line passing through 2 points, what we've been saying is we're going to use x1, y1, yeah?
Yep.
So
X2, Y2.
x1, y1. And remember, it doesn't matter which one you pick. x2, y2. So I'm going to try and find m first. Okay. So the other thing is we're going to be using as well, because we've been given 2 points, we're going to use y minus b equal mx minus a. And I've picked here a and b being the positive one. So you could pick a and b as well if you wanted -1, -7. So m is y2 minus y1 divided by x2 minus x1. 3 minus minus becomes a positive, so 3 plus 7 plus 10 over 5. So straight away m is equal to. So quick thing, I've got a positive gradient. Is my line going up? Yep. So that feels good. So I'm quite happy. Then I'm going to change and replace a and b with 4 and 3 and m as well too. So now we just got to solve this. Y equal 2x. Thing is we see mess sometime is, remember when you time not only the first parameter there, but you time as well the 4. So that's the common thing missed. So it's 2x minus 8, and then 3 goes on to the other side, or you add 3 both ways. So if you were to do your work, and you can just say, I'm going to add plus 3 both sides. Then you end up with y equal 2x minus 8 plus 3, which should be y equal 2x minus 5. Okay. So that would be worth quite a few marks. So mark for the gradient. Mark to know this is y minus b, and mark for solving this. So that would be like 3 marks. 3, right up to 4. Sometimes I've seen it, but yeah, a minimum of 3 anyway. This question as well, 27 to the power 2/3. I've seen it being a bit of a,
Rule number 6 or 7.
So,
root 3 root 27 to
yeah.
the power of 2.
So the way you would say is 27 over 2/3 is the same as 27 1/3, but all that squared. Because what happened here is you get 2 times 1/2 is 2 over 3. So if you write it like that, remember you've got it's a fraction here and a fraction there. Now what's 27 to the power 1/3?
3. No, it's not. It's not.
So is this? That's the same thing. Yeah, cube.
27.
So cube root of
Cube root,
27.
sorry, cube root squared. Yeah.
Yeah. So if it's 25 a power of a half, it means it's 25 square. Square root of 25, sorry. But we don't put the 2 in front. But because it's a cube root, you need to put the 3. So cube root of 27. So a number that we time it by itself and time it again
9.
by itself. So 9 times 9, that's 81. That's
3.
too big. So yeah, 3. 3 times 3 is 9. Times 3 is 27. Yeah.
3.
So it'd be 3. So I've got 3. And then once I get my 3, I need to square it.
Yeah.
So 3 square, which give me at the end 9. So your final answer should be 9. But in order to get 2 marks for this, for example, you need to show that you've cube root the 27 and that you've squared your answer. So that's how you would show your 2. So here I've put them step by step. Step by step. Okay. So for this one, I've got to solve an equation. So they've asked me to find x. So the first thing you do is whenever you're going to get a fraction like this with a function above it, I need to get rid of the fraction. To get rid of a divide by 3, what do? We need to do the opposite of dividing by 3, both sides, and it's timing by 3. But when you time, remember you time the whole side, not just 2x. You need to time 2x minus 1. And in order to do that, you need to put the bracket. So that means 3 times 2x minus 1 equal x minus 4. And if you don't want to forget about s, what you could do is, whenever you get s, the first thing you could do is, you know what, I'm going to put brackets here. And if you want, you can even put brackets here. It doesn't do any harm.
How did
And
you
now,
do that again? Sorry.
so you
Did
need,
you go across the way and then?
yeah, so you need
like
to
a
time
smile
by
like this?
3. You need to time by 3 both sides to get rid of that fraction. Because 3 divided by 3 will become 1. So what we've done is we've timed by 3 that side. 3 times 2x minus 1 is just 1 times x minus 4, which is x minus 4. And now you expand. 3 times 2x is 6x. 3 times negative 1 is negative 3 equal x minus 4. And this time we should be able to solve this because we're going to add x. We're going to take away x both sides, and we're going to add 3 on both sides. So take away x both sides will give me 6x minus x, and add 3 both sides will give me 3 minus 4, which is negative 1. And your final answer should be divide by 5 both sides. You get minus 1 over 5. Okay. And if you get extra, if you finish this and you still get 5 minutes and your teacher asks you, oh, just check a few of your answers, take that. If you got your calculator, plug it in here and see if it works. So you would get your calculator, you would say, you know what, I've got a couple of minutes. I'm going to do 2 times minus 1 over 5. Take away 1. You calculate that on your calculator. It will give you an answer. And on the other side, you do minus 1 over 5. Take away 4. And you divide all that by 3. And if you've done your work correctly, whatever you're going to get here should be exactly the same as here.
Yeah.
Because if it's not, then somewhere we've made a mistake. So 2 times open bracket fraction negative 1 over 5 close bracket minus 4. It gives me minus 22 over 5. So that's what I get here, minus 22 over 5. Now do the same on the other side. So I'm going to start with a fraction, open bracket, minus 1, minus a fraction. So minus 1 over 5, close bracket, minus 4. The whole thing divided by 3. Oh, it's not 22 over 5. It's 7 over 5. Yeah, minus 7 over 5, sorry. I didn't enter 1 there, I enter 4. So it's -7/5. And when I did this one as well, I got -7/5. And now I know that x equal -1/5 is the correct answer, because my left-hand side is exactly as my right-hand side. Okay. Any question on that? Solving equations with a fraction?
Never seen one like that. The ones I've seen in
Yeah.
class where we'll find it, express it in its simplest form, like as a single fraction, those kind of ones.
Yeah,
That's
so
it. Particular.
What you could do is whenever you're going to see example that we've seen sometime is you can have a fraction like, I don't know, 3x plus 6 divided by 2 equal 5x minus 1 divided by, I don't know, 3. And they ask you solve this. So what you do is you get rid of the 3 here by timing by 3 both sides. Oops, what happened there? So you end up crossing that 3 here. So it becomes 3 times 3x plus 6 equal, you cross that 2 on that side, 2 times 5x minus 1. So technically what we've done is we've timed both sides by 3, which got rid of that 3, and we timed both sides by 2, which got rid of that 2. And now this is easier. So now you can solve this because it's just 9x plus 18 equal 10x minus 2. And now you're on more familiar territory, okay? And that's how you would do them. What is the equation of the graph? So I'm looking at this and straight away, because I'm not starting at 0, I know this is a cos and it's starting at 2. So that's a 2 there. So 2 cos something. And I've got here 90 degrees. So how many of those can I fit within 360? I can put 4 of these within 360. So then I know this is 2 cos x, 2 cos 4x basically, yeah. Yeah, remember? How many can I fit within 360 is that number. And the amplitude is just going from 0 to 2. Okay. Trig graphs. We've done some of these. So standard deviation. So now they've told us that the standard deviation is √3. Show that the standard deviation is √3. So we need to show our working. So first thing first, you would put a table together. Not the right one. So it's this one here. You've got 1, 1, 1, 2, 5. So n equal 3. Sorry, n equal 5. You would do the x bar. So you need to find what x bar is. So you add them all up. So that's 10. 10 divided by 5. So you've got x bar equal 2. Yeah.
Yep.
Remember how you do your mean? Add them all up, divide by the number that you've got. Then now you do x minus x bar. So 1 minus 2 is -1. 1 minus 2, 1 minus 2. So 3 of them. 2 minus 2 is 0, and 5 minus 2 is 3. And quickly you can add all these up. 3 minus 1 minus 1 minus 1 is 0. So I've got a good feeling that I've got the right answer here. Now we square them all. We get 12. And we're going to use the standard deviation formula, which is √12 over, remember it's n minus 1, which is 4, which is √3. So now you've shown that the standard deviation is √3, and we've got the right answer. So you get 1 mark for this table, 1 mark for the mean, and 1 mark for showing it. So this question would be 3 marks. Okay. Now they've asked us to write down the standard deviation for 101, 101, etc. So you could go and do all this just the same way. But what you'll notice is you have 100 plus the 12, the 10 values here. So you've got 5 times 100. So instead of being 2, your mean this time is going to be 102. So when you're going to do the deviation x minus x bar, you're going to get exactly the same value for x minus x bar. This is because it shows that when you've got a set of data and you've got a mean for that set of data and a standard deviation, if you add to every data point the same amount, the standard deviation and the mean won't change. Sorry, the standard deviation won't change. The mean will just be added 100 to it. So the original mean was 2. The new mean is going to be 102. Okay. And that's why that the standard deviation is going to be the same. So the first part to get a mark, we prove it. And the second one, you just do the standard deviation, which is the same thing, √3.
Yep.
So we've just shifted all the data points by adding 100 to it. So that means we shifted the mean, but the standard deviation stayed the same. So if we had like a, what we call a bell curve for that data, we've just shifted it by 100. Okay.
Mhm.
Multiplying out. So we've done quite a few of those before.
Mhm.
In order to do that, remember, every term needs to be timed by 2. And the thing to watch for is if you, this 2 here is positive 2, right? If you don't have anything in front of it, it means positive. If it was a negative, they would have put the minus. And when you do a positive time a negative, you will get a negative. So that's the second bit that people might get wrong. Now, negative x times x is negative x squared, whereas a negative x times a negative 3 become positive 3x.
Negative times.
So these kind of thing would give you 2 marks, 1 mark for the first part, done correctly, and a second mark for the second one here.
-9 x.
And then after multiplying out, we need to simplify. So that's going to be the third mark. So 2x squared minus x squared. So you group the likes is x squared.
Minus
Negative
8x.
8x minus 3x. That's minus.
11x.
Ooh. That's plus 3. I made a mistake.
Oh.
Hold on. Hold on, hold on. This is plus. I just said that a negative times a negative is a positive. So negative 8x plus 3x. Remember, a negative x times a negative 3 is a positive 3. Okay? And that's why your final answer would be minus 5x and the last plus 6 on its own. Okay?
Yep.
But remember, I said plus 6 on its own. But technically, plus 6 is 6x to the power 0. Yeah? What's x to the power 0 again?
1.
One.
Yeah. So that's why a quadratic, they put x squared and x, but it's x squared, x to the power 1, and x to the power 0. Because we write x to the power 1 as just x, but x to the power 0 is 1. So that's why we don't write it. Okay? So you've learned something today. Anything that you can write with x squared, x Remember, there's an x0 coming after it. So Rob normally cycles a total distance of 56 miles per week. We've been told that he increases his distance by 15% each week for the next 3 weeks. How many miles will he cycle? So the important thing here to highlight is for the next 3 weeks. So that means I'm going to have to put something to the power of 3.
Can we use that formula? The V
Yeah.
equals.
So what I would say here, I would do 56 times 1 plus 15% to the power of 3. So if you type that in your calculator, just exactly the way it appears there.
85.169.
And you should get 85.169 miles. So in the third week, if it increases every week by 15%, it would be cycling for 85.169. So the mistake we see is some people will say, oh, I would rather put 100 plus 15 divided by 100. You can do that, it'll be fine, because you get 115 divided by 100, which is 1.15. Or 1 plus the 15%, because the 1 is just 100%. Okay. This is the typical depth of water in the cylindrical tank. Calculate the radius. So what we're looking for here is this value. The radius is from the center there, right up to that point. That's what we're looking for.
So it's Pythagoras' theorem.
They've told us, yeah, AB is 18. So from this point to B, I've got half of 18. That is 9. The water, the depth here is 5 meters. Yeah. So x plus 5 is what we're looking for. So how can we do this step by step? So first thing, you put that x square equal the radius square, take away 9 square. Do you agree? Pythagoras. One of the short side is the long side, which is what we're looking for. Take away 9, take away the other short side. So that's one thing. And the other thing that we know is x plus 5 is the radius. Because from the point there to the circle edge, you get the radius. So what I could do, I can either replace x with r minus 5 or just replace r with x plus 5. And if you replace r with x plus 5, you end up with this equation, which is x squared plus x plus 5 squared minus 9 squared. And if you expand that, you get x squared equal x squared plus 10x plus 25 minus 81. Now I've got x squared here, I've got x squared here, so I can take them away both. And I end up with 10x equal 81 minus 25, or 56 equal 10x, which means x equal 5.6. But remember, I'm looking for the radius, not just x. So the radius now is going to be x plus 5. So what's 5.6 plus 5? 5.6 plus 5 is 10.6, which is what they gave us. Okay. So 10.6 meter. Yeah.
Yeah.
That makes sense because if the radius was 9, and I've got here 5 plus 5.6, sorry, if this side was 9, not the radius, we found x equal 5.6. The radius is going to be bigger than those two, and that's why the radius is 10.6. So my values do make sense. So in here, we're using trig identity. So the way to do this is to write that tan x divided by sine x on the left-hand side, replacing tan x with sine x divided by cos x.
Mm-hmm.
But because you divide by sine x, it's the same as dividing by sine x over 1. So how do we divide two fractions? We use
Flip
KFC. Yeah, we flip the second one
the second one. So
and we change the divide with a multiply. Yeah. And now I've got sine x times 1 and cos x times sine x. You can just simplify the sine x and sine x. And that should give you sine x. So use tan x. Now we've proved that that left-hand side is the same as 1 over cos x, because what you would, to finish this off, you would just say, I can simplify that, and that is just 1 over cos x. And this is what you would call the right-hand side, for example, of your equation here. And this is what we call the left-hand side. So we've just proven that left-hand side equal right-hand side. Okay.
Mm-hmm.
So we're going to take a 10 minutes break. And then when we come back, I can walk you through the paper A, the practice paper I sent you. How would you go about working with that type of paper during your revision? So those are just practice paper. Okay, and what I'll do is I'll finish off the working for the last 30 questions that are here, and I'll email it to you over the weekend. So at least once you're done, you can have a look. Yeah, you've got all the 100 questions.
That's fine.
And remember that came with another file. Whenever you get stuck, you can always look at a quick guide.
I tried not to look at that because I thought if I look at one, then
yeah,
I'll try and look at another. So we tried to leave it until we were done it.
Yeah. Okay, so I'll finish that off and then send it over the weekend. So at least you've got all the working for all the questions. Okay, so I'm gonna stop